The solar system is made up of the Sun, the planets that orbit the Sun, their satellites, dwarf planets, and many, many small objects, like asteroids and comets. All of these objects move, and we can see these movements. We notice the Sun rises in the eastern sky in the morning and sets in the western sky in the evening. We observe different stars in the sky at different times of the year. In this lesson, you will learn about how the movements of the Earth, Moon, and Sun affect different phenomena on Earth, including day and night, the seasons, tides, and phases of the Moon. The Earth rotates once on its axis about every 24 hours. If you were to look at Earth from the North Pole, it would be spinning counterclockwise. As the Earth rotates, observers on Earth see the Sun moving across the sky from east to west with the beginning of each new day. We often say that the Sun is rising or setting, but actually, it is the Earth's rotation that gives us this perception of the Sun rising up or setting over the horizon. When we look at the Moon or the stars at night, they also seem to rise in the east and set in the west. Earth's rotation is also responsible for this. As Earth turns, the Moon and stars change position in our sky. It is a common misconception that summer is warm and winter is cold because the Sun is closer to Earth in the summer and farther away from it during the winter. Remember that seasons are caused by the 23.5-degree tilt of Earth's axis of rotation and Earth's yearly revolution around the Sun. This results in one part of the Earth being more directly exposed to rays from the Sun than the other part. The part tilted away from the Sun experiences a cool season, while the part tilted toward the Sun experiences a warm season. Seasons change as the Earth continues its revolution, causing the hemisphere tilted away from or towards the Sun to change accordingly. When it is winter in the northern hemisphere, it is summer in the southern hemisphere, and vice versa. Another effect of Earth's rotation is that we have a cycle of daylight and darkness approximately every 24 hours. This is called a day. As Earth rotates, the side of Earth facing the Sun experiences daylight, and the opposite side facing away from the Sun experiences darkness or nighttime. Since the Earth completes one rotation in about 24 hours, this is the time it takes to complete one day-night cycle. As the Earth rotates, different places of Earth experiences sunset and sunrise at different times. As you move towards the poles, summer and winter days have different amounts of daylight hours in a day. For example, in the northern hemisphere, we begin summer on June 21st. At this point, the Earth's north pole is pointed directly toward the Sun. Therefore, areas north of the equator experience longer days and shorter nights because the northern half of the Earth is pointed toward the Sun. Since the southern half of the Earth is pointed away from the Sun at that point, they have the opposite effect, longer nights and shorter days. For people in the northern hemisphere, winter begins on December 21st. At this point, it is Earth's south pole that is tilted toward the Sun, and so there are shorter days and longer nights for those who are north of the equator. A solar eclipse occurs when the new moon passes directly between the Earth and the Sun. This casts a shadow on the Earth and blocks our view of the Sun. A total solar eclipse occurs when the moon's shadow completely blocks the Sun. When only a portion of the Sun is out of view, it is called a partial solar eclipse. Solar eclipses are rare events that usually only last a few minutes. That is because the moon's shadow only covers a very small area on Earth, and Earth is turning very rapidly. As the Sun is covered by the moon's shadow, it will actually get cooler outside. During a solar eclipse, the corona and solar prominences can be seen. A lunar eclipse occurs when the full moon moves through the shadow of the Earth. This only happens when the Earth is between the moon and the Sun and all three are lined up in the same plane, called the ecliptic. The ecliptic is the plane of the Earth's orbit around the Sun. The Earth's shadow has two distinct parts, the umbra and the penumbra. The umbra is the inner, cone-shaped part of the shadow in which all of the light has been blocked. The outer part of the Earth's shadow is the penumbra, where only part of the light is blocked. In the penumbra, the light is dim but not totally absent. A total lunar eclipse occurs when the moon travels completely in Earth's umbra. During a partial lunar eclipse, only a portion of the moon enters Earth's umbra. A penumbral eclipse happens when the moon passes through Earth's penumbra. The Earth's shadow is quite large, so a lunar eclipse lasts for hours and can be seen by anyone with a view of the moon at the time of the eclipse. The moon does not produce any light of its own. It only reflects light from the sun. As the moon moves around the Earth, we see different parts of the near side of the moon illuminated by the sun. This causes the changes in the shape of the moon that we notice on a regular basis, called the phases of the moon. As the moon revolves around Earth, the illuminated portion of the near side of the moon will change from fully lit to completely dark and back again. A full moon is the lunar phase seen when the whole of the moon's lit side is facing Earth. This phase happens when Earth is between the moon and the sun. About 1 week later, the moon enters the quarter moon phase. At this point, the moon appears as a half circle, since only half of the moon's lit surface is visible from Earth. When the moon moves between Earth and the sun, the side facing Earth is completely dark. This is called the new moon phase, and we do not usually see the moon at this point. Sometimes you can just barely make out the outline of the new moon in the sky. This is because some sunlight reflects off the Earth and hits the moon. Before and after the quarter moon phase are the gibbous and crescent phases. During the gibbous moon phase, the moon is more than half lit, but not full. During the crescent moon phase, the moon is less than half lit and is seen as only a silver or crescent shape. It takes about 29.5 days for the moon to revolve around Earth and go through all phases. Tides are the regular rising and falling of Earth's surface water in response to gravitational attraction from the moon and the sun. The moon's gravity causes the oceans to bulge out in the direction of the moon. In other words, the moon's gravity is pulling upwards on Earth's water, producing a high tide. On the other side of the Earth, there is another high tide area, produced where the moon's pull is weakest. As the Earth rotates on its axis, the areas directly aligned with the moon will experience high tides. Each place on Earth experiences changes in the height of the water throughout the day as it changes from high tide to low tide. There are two high tides and two low tides each tidal day. During a spring tide, the sun and the moon are in line. This happens at both the new moon and the full moon. The sun's gravity pulls on Earth's water, while the moon's gravity pulls on the water in the same places. The high tide produced by sun adds to the high tide produced by the moon. So spring tides have higher than normal high tides. This water is shown on the picture as the gray bulges on opposite sides of the Earth. Notice that, perpendicular to the gray areas, the water is at a relatively low level. The places where the water is being pulled out experience high tides, while the areas perpendicular to them experience low tides. Since the Earth is rotating on its axis, the high-low tide cycle moves around the globe in a 24-hour period. Now the second picture shows a neap tide. A neap tide occurs when the Earth and the Sun are in line, but the Moon is perpendicular to the Earth. This happens when the Moon is at first or last quarter moon phase. In this case, the pull of the gravity from the Sun partially cancels out the pull of gravity from the Moon, and the tides are less pronounced. Neap tides produce less extreme tides than the normal tides. This is because the high tide produced by the Sun as to the low tide area of the moon, and vice versa. So high tide is not as high and low tide is not as low as it usually might be.